are you? And
I'm Wayne Yoshida, KH6WZ.
Oh, thanks. What's going on here today?
Well, our theme is called Not Your Grandpa's Ham Radio. The reason we're doing this is because we want to sort of change the perception of what ham radio is. We're doing a lot more with current technology and technologies that are fairly new, including software-defined radios, as well as experimenting and building two-way radios for microwave frequencies.
So what's a software-defined radio?
Well, we're looking at ways to use the power of computing to enhance received radio signals. So in addition to the old-fashioned way of listening to it by ear, we're using the capabilities of computers and, so for example, signal processing to make more intelligible information or signals from radios. We have here some kit-built products.
Oh, let's go take a look at those.
It's called an Ellsworth KX3. It's very portable. You see in the background the analog meter moving. It's actually connected to this Arduino beacon. And for the hams out there, no CW, they're listening to the message right now. Hopefully you can decode it. And no, I will not tell you what it says. You'll have to find that out. The analog meter is called a field strength meter. And as you can see, it's detecting RF energy coming out of the loop antenna to the left. Jeri, you built one of those a while ago, didn't you?
I sure did.
So the interesting thing about this, which blows some kids away, is that one, you see the meter deflecting, but you know what? There's no battery in here.
Oh my, how does that work?
So we have a couple of diodes in here, rectifiers, and it's configured into a voltage doubler circuit, and has some miscellaneous other passive components that will try to shape or determine frequencies for it. The unbreakable antenna you see is, yes, indeed, from a tape measure.
All right, what's going on here?
Well, let's see. This young guy is exploring our keyboard to Morse code translator. It also has a beacon mode, so when you type a character on the keyboard, you can hear it translate into Morse code. Now, as a fun test, sometimes I will ask somebody to spell his or her name, and I'll turn my back on them, not to be impolite, but to prove to them that I can read the Morse code by sound rather than by watching the key. Kind of fun.
Yeah.
Folks, a lot of folks know what a Tesla coil is, but maybe not something this tiny. We're using it here to simulate lightning. So to first prove that it's kind of, if it's turned on, I use this compact fluorescent bulb, right? Might have this at home. And as you can see, without wires, it can still has enough energy at 7,000 or so volts, but very little current that it can illuminate the fluorescent bulb.
What's happening inside that tube there? Why is it lighting up?
Excellent question. It's got, I'm going to say it's phosphorescent material inside, and it gets excited, if you will, because the electrons and energy is creating an energy field that makes it glow. Similar is something called this. It's an electroluminescent, or EL, unit. You might see these in the back of computer displays or LCD displays. So yes, it's on.
Look, Ma, no wires, right?
Yes.
It's just going right in.
So here, like I said, danger high voltage. Come closer, but don't touch. Have a piece of wire here that could simulate your finger. And if we stick it in the hole, if you look really closely, you'll see maybe a very tiny spark. I can only get this to make a spark about 1/8 of an inch or so,
yeah, look at that.
But that's because it's maybe very, very small microwatts of power. But if you look over there across the booth, if you watch for the little yellow light and the meter deflecting, it's actually detecting the lightning activity.
There it is.
Somewhat related to measuring energy is this setup. This is an X-band test source. Actually came from an old garage door opener, probably from the 60s or 70s. It's called a gun diode.
X-band is microwave, right?
Yes, and in fact, if anybody who has a radar detector, you'll see one of the things that'll detect is X-band, and that's what this is. It's 10 gigahertz, so this is a COPS radar gun frequency. And right now we're gonna just see what it does energy-wise as it comes out. Microwaves have a polarization. It's now horizontally polarized because inside here there's a probe that goes this way.
Okay.
If I turn the horn this way, it's then vertical polarization. This is the sensor element, which is a piece of wire. It's horizontally polarized. So when we do this, it can detect energy at its horizontal polarization. But if we tilt it 90 degrees, it goes down in strength because of the difference in polarity. To optimize the signals, a transmitter and a receiver should have matching polarities.
Very nice, very nice. Why would anyone in ham radio want to do microwave stuff since it's such line of sight?
It is not line of sight. I'm glad you asked that question because this is a transmitter section of my radio. Unfortunately, the IF section, the other smaller radio, is broken in shipment, so I don't have that out. But this is a system that translates or converts one transmitter into another or higher frequency. So there's some math, and this is how electronic modules called mixers multiply for transmit or divide for receive. So up conversion is transmit and down conversion is a fancy term for receive. So if we look at the numbers here, this is basically what happens in terms of frequencies and the multiplication factors to get to 10,368 megahertz or 10 gigahertz.
That's a lot of hertz.
That is a lot of hertz. Hurts a lot for me to think about it sometimes.
Yeah. Yuck, yuck, yuck.
So here, I actually have a sticker because in, what was this? 2007, I had a North American record. Of course, there's two people, right? Because one's a receiving station and a transmitting station. Best DX, best longest distance this radio system has ever had. Two-way CW, Morse code, 1,448 kilometers or 899 miles in August 2007.
So how did you do that? Did you just walk out your door and just do it from your garage, or?
No. I was in Northern California. The other station was in Baja California. So what happens is, fortunately here on the West Coast, we have a propagation mode for microwaves called tropospheric ducting. So that's actually very weather related and it's quite predictable. So what happens is the layers of smog and other things in our atmosphere create a duct, right? Almost like a pipe that goes up and down the coast. There should be, during these times of that kind of weather, right? So temperature and humidity factors are all okay in the right conditions. We have a path that goes probably as far down as Mexico all the way up to the entire West Coast. That propagation mode has not been completely experimented with, and we still don't know how far that duct goes. It could be way past where we were from Baja to Northern California. So it's more fun to explore.
Did you have to climb mountains to do that?
No, as a matter of fact, we had to be lower than mountains because sometimes what happens is if you're in a mountaintop and because of the weather here, right, we have a smog inversion layer. So what happens is sometimes when you're high mountaintop, some people think that's better for line of sight. No, because the inversion layer blocks radio signals. So you've got to go underneath it or below the inversion layer to make successful microwave contacts. Very
cool.
Interesting, kind of counterintuitive sometimes. Every time you see the yellow light flash, it's actually an LED, and the meter deflect. Lightning is happening somewhere. Could be a Tesla coil, could be somebody's charcoal igniter. If you have a gas barbecue, you probably know what this is. Take a look. I don't know if you can see that.
There it is.
So if we go really close to the antenna, which is another tape measure, you can see that deflect also.
It's also handy if you want to know if your neighbors are kicking on their barbecue. And
or if you want to cook a nice rack of ribs.
Yeah.
But that's another YouTube channel. So this unit is my art piece.
Yeah, this looks glorious. What is it?
I call it inventory reduction. And it's actually a very, very cool panel from an aircraft tanker. And when I bought it just because it was so neat I just had to have it. So what is it really? It does nothing. It's a kid's toy. So if you flip switches, you can turn things off and on. But this is my favorite button right here. This was inspired because I was at a Maker Faire several years ago, and I noticed really small kids sometimes get really, really bored. So I wanted to give them something to do.
Let me guess, this is the most popular thing in the booth?
Yes. Sometimes, more often than not, it is the most popular thing in our booth.
What's the second most popular thing?
Second most popular thing? Our lightning detector.
Nice.
So one last thing we have, actually, second to last thing, Ellsworth K3S.
Nice radio.
So this is a company called Ellsworth, and Ellsworth makes kit radios. Some people out there probably remember Heath kits. So since this is not your grandpa's ham radio, this is today's ham radio, and guess what? Ellsworth makes kits for us once again. Well, most of our kit, none of the Ellsworth kits have tubes. The Heath kits always had tubes. Well, many of them did. But now here's our newest version of kit building.
That looks like a lot of work to put that together. How many hours does it take to assemble one of these?
That's a good question. For me, it's pleasurable, so I don't keep track of time. I just keep working until I need a break. That's it. That's the satisfaction of getting something done and it works.
A lot of bang for the buck if you get
That's
that.
right.